All right, let's take the derivative of this function here. Now, what we have a bunch of times is power rule, power rule, power rule. Power rule says that if I were to take the derivative of something times x to the nth power, right? If I were to take the derivative of that, what you're going to do is drop the n down and multiply it to c, so n times c, and then subtract 1 from n. So it's going to look like that. That doesn't really look like that, though. If you're like, well, what about square roots? What do I do? It's an easy fix. What we're going to do is we're going to change the square root of x into x to the 1/2. Okay? 3 is going to stay 3. We're going to take the cube root of x and turn that into x to the 1/3, and 2 stays 2. So now that I have these as number exponents, I can drop the 1/2 down and subtract 1. Drop the 1/3 down and subtract 1. All right, we'll get to that too in a minute. So f prime of x is going to be 1/2 x to the 1/2 minus 1 is negative 1/2. Okay, now we're going to bring down the 1/3, so plus 1/3 times the 3 that's already there. X to the 1/3 minus 1 is negative 2/3. Okay? Now, the derivative of a constant number disappears, goes away, gone, donezo. So that makes life easier. Let's clean this up a little bit. Okay, so we'll take 2 steps to clean this up. F prime of x is going to equal negative exponent. Let's drop it down with the 2, so 2 times x to the 1/2. Okay, 1/3 times 3 is just 1, so we'll pretend that that's not even there. And then we'll drop this down to the bottom and make that x to the 2/3. Now let's clean this up one more time by turning it back into its radical form. So 1 over 2 times the square root of x plus 1 over the cube root of x squared. Okay, so everything is now done. Everything is clean. Everything is lovely. I'm happy. That's my answer. Take the derivative of f of x equals 1 over the square root of x plus 3 over the 5th root of x squared. This is going to use the power rule. Now, the power rule says that if I were to take the derivative of something in the form of whatever times x to the nth, you drop the n down and multiply it to that c, and then you subtract 1 from n. This, though, and these guys don't look the same at all. So let's change f of x using 2 steps. Let's turn this into 1 over x to the 1/2. So now that I have the exponent, okay, that's good. And let's turn this into 3 over x to the 2/5. Okay, now I still can't apply this rule because this rule only works if things are in the numerator. So how can I fix that? Well, let's write this out as f of x equals, bring both of you upstairs and make the exponents negative. So 1 over x to the 1/2 is going to be x to the negative 1/2. Plus 3 over x to the 2/5 is going to be 3x to the negative 2/5, like so. Now I can take the derivative. Now I can say that f prime of x is going to have me dropping this down and subtracting 1. Dropping this down and subtracting 1. So dropping down the negative 1/2, okay, x to the negative 1/2 minus 1. I'll clean that up in a bit. Okay, plus drop down the negative 2/5 multiplied to that 3 that's already there, x to the negative 2/5 minus 1. Let's clean this up using 2 steps. F prime of x is going to equal negative 1/2 is still there. Okay, x to the negative 3/2, because 1/2 minus 1 is negative 3/2. You don't do much. Negative times a positive is a negative, so that's going to be negative 6 over 5. And negative 2/5 minus 1 is negative 7 over 5. So actually 2 steps after this. Okay, I lied. I'm a liar. Sorry. Step number 1, let's move the negative exponents downstairs. So negative 1 over 2x to the 3/2 minus 6 over 5x to the positive 7/5 And let's clean that up by saying f prime of x equals negative 1 over 2, and we'll do the square root of x cubed, okay, that's the 1, minus 6, oh boy, over 5, the fifth root of x to the 7th. So let me write it out up here. That looks awful. That looks awful. Let me write it out up here in a different color. F prime of x equals negative 1 over 2 square root of x to the 3rd minus 6 over 5 fifth root of x to the 7th, I believe it was. Yeah. So definitely not the prettiest problem in the world, but we did it. Take the derivative of y equals 1 over x to the 3rd minus a half x to the 4th plus ex squared. Now, this is going to use the power rule 1, 2, 3 times. The power rule says if I were to take the derivative of some number times x to the nth, okay, bring that n down and multiply it to that c, and then subtract 1 from that n, like so. I can't do this rule yet because I have x on the bottom of a fraction in the denominator, but all I have to do to clean this up is move that x up here and make it 1 times x to the negative 3rd, and then I'm cooking with gas. So this is fine, and even though that e seems scary, trust me, it's fine. Now, the derivative is going to be y prime, or you can call it dy dx. We're going to bring that negative 3 down and then subtract. So that's going to be negative 3x to the negative 3 minus 1. Okay, minus. Let's bring that 4 down and then subtract. So 4 times 1/2 x to the 4 minus 1. Let's bring that 2 down and subtract. So plus 2e to the x, or ex to the 2 minus 1. Let's simplify. Negative 3x to the negative 4th. Negative 4 times a half is negative 2, x to the 3rd. 2e is just 2e. 2 minus 1 is invisible 1. Okay, so let's clean this up one more time. Y prime equals this. One more step and we'll be done. Negative 3 over x to the 4th, right? Because x moves to the bottom. Nothing changes here. And again, that invisible 1 is not necessary. And that's what I end up with. Power rule, baby. I love the power rule. It's so bad. It's from a movie called The Wizard. He says power glove, though. Like and subscribe. You are given f of x equals 1/2 x to the 4th minus 4x to the negative 2 plus e, and my job is to find f prime of 3. Well, this is going to use the power rule not once, not twice, but thrice, kind of. The power rule says that if I were to take the derivative of something in the form of some number that I'll call c x to the nth power, okay, I'm going to drop down that n and get n times c of x to the n minus 1. So you drop your exponent down, multiply it to the number that's already there, and take 1 away from your exponent. Now, I can't do that yet. No, actually, I can. Everything's in good shape. I have my, x to the 4th, x to the negative 2, and no x there, so that's going to be all right. It's going to be pretty easy. So f prime of x, okay, has me dropping down the 4 and subtracting 1. So multiply 4 to a half, and then I get x to the 4 minus 1. Okay, minus, drop down the negative 2, so I have negative 2 times 4, x to the negative 2 minus 1. And if I take the derivative of e is just a number. The derivative of a constant is 0, so I don't need anything there. So I have a little bit of cleaning up to do. F prime of x is going to equal 4 times a half is 2. Okay, 4 minus 1 is 3. Negative times a negative times 2 times 4 is going to be positive 8 x to the negative 3rd. Now, let's clean this up just a teensy bit more. Let's just make this 2x to the 3rd, and we'll drop that negative exponent to the bottom and make it x cubed. Am I done? Nope, because my job is to find f prime of 3. So f prime of 3 has me substituting 3 for every x. So I get 3 cubed times 2 plus 8 over 3 cubed again. So 3 cubed is 27. 3 cubed is 27. So that's going to be, what, 54 plus 8 over 27 is going to be 54 and 8/27. So I'm not going to lose sleep trying to simplify that. I'm going to let it go like that. Not the prettiest thing in the world, but that's my answer. I like this one. This is going to be pretty fun. Given g of x equals 2x to the fifth plus b, where b is some number, some constant that we don't know, over x squared, find the value of b if g prime of 2 is 180. So what I have to do is I have to take the derivative of this guy. Before I can take the derivative, let me rewrite it out. G of x is going to equal 2x to the fifth. Now I'm going to use the power rule. Okay. This isn't good for the power rule right now because x is on the bottom, so I'm going to move x to the top and make it x to the negative 2 power. Now I can apply the derivative. G prime of x has me dropping this 5 down and multiplying it to 2, so drop the 5 down, multiply it to 2 times x, and subtract 1 from here. So 5 minus 1. Drop this negative 2 down, so plus negative 2 times some b, and then we're going to subtract 1 away from that negative 2, so negative 2 minus 1. Okay, so simplifying that, g prime of x is going to be 5 times 2 is 10, x to the 5 minus 1 is 4, plus, actually minus, so let's get rid of that. Let's get rid of that. Minus 2b, or not 2b, x to the negative third. Shakespeare joke. It's okay. Now what do I do? Well, I know that if I replace x with 2, I get 180. All right, so if I replace x, so g prime of 2 is 180, which means I replace each of these x's with 2. Maybe before I do that, why don't I quick rewrite this so that it looks like that. And now what I'll do is I'll replace every x with 2. So I get 10 times 2 to the fourth, minus 2b over 2 to the eighth. Third, I'm sorry. I accidentally jumped ahead and did it. All right, so let me move this over here where I'm probably going to need the space. We have 180 equals 10 times 2 to the fourth is going to be 10 times 16. Minus 2b over 8. So 180 is going to equal 160 minus b over 4. Now it's a two-step equation. Subtract 160, subtract 160. On the left side, you get 20 equals negative b over 4. Right? Multiply both sides by negative 4. Multiply both sides by a negative 4. That crosses out along with the negatives, and b equals negative 4 times 20 is negative 80. What a strange problem. I liked it though. You had to think about it a little bit, but you know, that's how you do it. Power rule, fun. Let f of x equal x cubed plus 2x minus 5. What is the x-coordinate of a point where the instantaneous rate of change of f is the same as the average rate of change of f on the interval negative 1 to 1. Whew. Okay, all right. Let's do this. This is a doozy. Let's find the average rate of change first. Okay, and I like to say AROC. The average rate of change is found by doing f of b minus f of a over b minus a. All right, you would be my A, you would be my B. So finding f of A would be me finding f of negative 1. Okay, and that would be negative 1 cubed, which is negative 1, plus 2 times negative 1, so minus 2, minus 5. So that gets you negative 8. F of regular 1, f of b, which is f of regular 1, is going to equal 1 cubed, which is 1, plus 2 times 1, which is plus 2, minus 5, and that's going to be negative 2. So f of b minus f of a is going to be negative 2 minus negative 8 over b minus a is going to be 1 minus negative 1. So u become plus sign, u become plus sign. That is 6 over 2, which is 3. So the average rate of change is 3. All right. So what I need is I need to find the x-coordinate of a point where the instantaneous rate of change of f is 3. Instantaneous rate of change is derivative. Now, I'm not going to use the definition of the derivative because I now know the power rule. So I'm going to say f of x, I'm just rewriting f of x equals x cubed plus 2x minus 5, just rewriting. I'm going to take the derivative of that using the power rule, all right? So drop down the 3, subtract 1 from 3, and that's what the derivative of x cubed is. Plus 2x, the derivative of 2x is just 2 because you would drop down the 1, invisible 1, and then get x to the 0th. And the derivative of a constant is 2. Now, we want our instantaneous rate of change to be 3. So 3 is going to equal 3x squared plus 2. And now I have to solve this abomination for x, which means, it's going to be bad. Minus 2, 1 equals 3x squared, right? Divide by 3, 1/3 equals x squared. Square root both sides, and technically we have a plus or minus, but I don't think they want us to do that here. They just want us to have the positive version. But this is going to be super annoying. Now I have x equals the square root of 1 over 3. They don't have that as an option. So you view this as x equals the square root of 1 over the square root of 3, which becomes 1 over the square root of 3. They don't have that as an option. So the way you get around that is you take that 1 over root 3, you multiply the denominator and the numerator by root 3 over root 3 to rationalize it. That gets you root 3 over root 3 times root 3, which is root 3 squared, which is just 3. And my answer is A. So that is a very, very, very tricky and very, very, very challenging problem. But we did it. And we had fun, didn't we? We did. Find the equation of the line tangent to f of x equals x cubed plus 2x squared minus 4 at x equals negative 1. I don't know what this looks like. But I know it's a cubic, and I know at some point x is going to equal negative 1, and I'm supposed to find the line tangent to that at negative 1. Well, what do I know? I know that the slope of the tangent line is found by taking the derivative. So in order to find this slope, I have to take the derivative of u. So slope equals f prime of x, which is going to involve me taking the power rule. Drop the 3 down, subtract 1. So drop the 3 down, subtract 1, u become u. Drop the 2 down, multiply it to 2, so I get 2 times 2 is 4. Subtract 1, x to the invisible 1. If I were to take the derivative of negative 4, I get nothing. Now, I care about my slope when x is negative 1. So I have to take f prime of negative 1 and plug in negative 1 to both x's. 3 times negative 1 squared plus 4 times negative 1. That gets me 3 times regular 1 minus 4, which is going to be negative 1. So my slope is negative 1. So the picture that I drew here, not that accurate. That's all right. It's not literally the picture that I care about, it's the equation. I have my slope. What I don't have is a point. I do have the x value of a point. So in order to find the y value of the point, why don't I plug that negative 1 into that guy and find my y value? So my y value is going to be f of negative 1, which is going to be negative 1 cubed plus 2 times negative 1 squared minus 4. Negative 1 cubed is negative 1. Negative 1 squared is 1, so 2 times 1 is plus 2, and then minus 4. Negative 1 plus 2 minus 4 looks to be negative 3. So my y value is negative 3. So what I have is I have a slope of negative 1 and the point of negative 1, negative 3. I'm going to use point slope form, y minus y sub 1 equals m times the quantity x minus x sub 1 to build my equation. All right, so y minus negative, so you would be my y sub 1, you would be my x sub 1, you would be my m, y minus negative 3 equals m, which is negative 1, times the quantity x minus x sub 1, which is negative 1. And cleaning that up just a little bit more, y minus negative 3 is y plus 3. I don't need the negative 1 part, I just need the negative. And x minus negative 1 is x plus 1. And that's a reasonable answer. And if you wanted to make that slope-intercept form, then distribute the negative and subtract 3 from both sides. Either way, this is acceptable, and this is going to be my slope of the tangent line of that cubic function at x equals negative 1.